Hi there, Mr. Holcomb here with another lesson in pre-algebra. This is a session 2 out of the supplemental books that are called Student Companion. So this is session 2 talking about exponents, okay, day 2. Applying properties for powers with the same base. Read and try to solve the problem below. So it says the population of a colony of single-cell bacteria doubles each day. So there's the first piece of information. Okay, the cells double each day. On day X, the population of the colony is 2 to the X. Okay, so the day is X. So the first thing I'm going to write now is I'm going to say let X equal the day, number of days. How about that? Number of days. Okay. How many times as large is the population of the colony on day 7 than on day 4? So we're using the exponential expression. Oh, excuse me. That's called an exponential expression. Okay. The exponent is a variable. The base is 2. So if we are on day 1, so over here I'm going to put the days. Let me write it like this so I don't have to write so much. So I'm going to write days here. And on day 1, that means let X be the number of days. Well, on the first day, then it's going to be, actually, this is day X. On day 1, this is going to be 2 to the first power. Whoops, what am I writing? 2 to the first power. Okay, day 1, the base stays 2, and the day is 1. On day 2, we have 2 squared. On day 3, we have the 2 to the third power, and so on and so on. On day 4, we have 2 to the fourth power. Day 5, that will be 2 to the fifth power. And day 6, 2 to the sixth power. And finally, day 7 will be 2 to the seventh power. And the reason that we're stopping at 7 is it says how many times as large is the population of the colony on day 7 than on day 4? Well, 2 to the 1 is 2. So on day 1, that's okay, the first day after. So here's day 1, there are 2 cells. Okay. On day 2, 2 squared equals 4. So there are 1, 2, 3, 4 on day 2. On day 3, 2 to the third power means 2 times 2 times 2, which is, okay, so on day 3, 2 to the third is 2 times 2, which is 4. 4 times 2 is 8. Okay, so that's going to become 8. Alrighty. Number 4, day 4. So this is the 8, by the way. Day 3, there are 8, and that's what we come up with using this formula. So now I can scroll up a little further. And 2 to the fourth, well, look what's happening. 2, 4. Here you might think, oh, we're just multiplying by 2, but no. 2 times 4 times 2 is 8, yes. Or maybe you might think they're doubling. Double 4, double 2, and that's 4. Double 4, and that's 8, and so forth. But then we get to 2 to the fourth power. That's 2 times 2, which is 4 times 2 is 8 times 2 is 16. So there it is. Okay. And 2 to the fifth is 32. And 2 to the sixth is, so really what we're doing is we're just multiplying. Okay. So 2 to the 1 is just 2. And 2 squared is 2 times 2. And 2 cubed is 2 times 2 times 2. So all we have to really do is, once we see a pattern in math, since this is 4 2's, multiply this by 2 and you're going to get this number here, right? Because we're just adding another multiple of 2. And instead of counting again and saying 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32, and then do the next one, okay, it would be a lot more productive if we just realized the pattern. And 2 to the 6 is 2 to the fifth times 2, or 32 times 2, which is 64. And 2 to the seventh will be 128. Okay, so let me get rid of this highlight because I want to highlight something else. Now, it said in the question, how many times as large is the population of the colony on day 7 than on day 4? Okay, so we want to focus on day 7, which is 2 to the 7th, which was 128 cells. And on day 4, there were 16 cells. So we're starting to, this is pre-algebra, so now let's set up an algebraic equation with that. So it says how many times as large as the population on day 7? So how many times is a variable times on day 7 than on day 4? So it would be day 4, 16 times some number x has to equal day 7, right? So how many times larger is day 7 than day 4? That means multiply day 4 by some number to get 7, day 7. So 16 times some number is 128. So to get x by itself, if I divide both sides by 16, then the 16s cancel here, leaving me with x. And then if I do this 128 divided by 16, 16 won't go into 12, but 16 will go into 128. I think 8 times, because 6 times 8 is 48, and 8 times 1 is 8, plus 4 is 12. Subtract, and there are no remainders. So the answer is, okay, the population of the colony on day 7 is 8 times larger than the colony on day 4. So the answer is 8 times larger. Okay, so moving on to this, model it. You can start with the population on day 4, which is 2 to the 4th. Double the population each day after that until day 7. So they did it in a table here. So 2 to the 4th, here is day 4, here's day 5, multiplying it by 2. Day 6 is multiplying it by 2 twice. And day 7 is multiplying it by 2 3 times. That's what they mean by double it. Okay. The relationship between the population on day 7 and the population on day 4 is those 3 2's times 2 to the 4th, which was the 4, all over 2 to the 4th. So they did it a little differently. Okay, and so then you can write each power as a repeated multiplication of the same factor. So population on day 7 is 2 to the 7th, and population on day 4 is 2 to the 4th. So if we write this as 7 2's in the numerator and 4 2's in the denominator, and then slide these 4 over to 4 of the 2's, so really what they're doing here is just lining these 4 up with these 4 and getting fractions. Well, anything divided by itself is 1. So 1 times 1 times 1 times 1 is just 1. So then we get left over the 2 cubed, which is 8. So we're going to lead into something here, and that's the rule for exponents and division. That's what this lesson's all about. So if I move up to the top here on page 2, or whatever page this is, 17, 18 in the book, it says, use the problem from the previous page to help you understand how to multiply and divide powers with the same base. But the thing is, they have to have the same base. That is a must, or this doesn't work. So 1A, what single power of 2 represents the relationship between the population of the colony on day 7 and the population on day 4? Well, we just did that right here at the bottom of this page, and it was right here. Whoops, forgot to go back to my pen or my highlighter. Okay, it's right there. It's 2 to the 3rd. Okay. All right. So it says, what single power of 2? So 2 to the 3rd. B says, look at the equation you completed in problem 1A, which is right here. How are the exponents on the left side of the equation related to the exponent on the right? Okay, well, we have a 7, and we have a 4. We have a 3. So what I'm thinking is the ones on the left, 7 and 4, you'd have to subtract them to get the number on the right. So the number on the right is the difference All right, so let's write that. The number. Actually, I'm going to do it a little differently here. I'm going to do a text box and type instead. I'm going to say the number on the, actually, let's say the exponent. The exponent on the right is the difference between the exponents on the left. Okay? So 2A says, look at the first model it. The table shows the population of the colony on day 7 as 2 times 2 times 2 times 2 to the 4th, which was day 4. How can you rewrite this expression as a product of 2 powers? Well, this is just asking us to identify that when you have 3 bases like this, you can take 2 and take it to the power of how many there are, and then it'd be times 2 to the 4th, which equals 2 to the 3 plus 4. Okay, from our previous lesson, when multiplying, you add the exponents. Okay. So as the product of 2 powers. So actually, we should have just stopped here. That's what this question asked. So I will erase that. Okay. B, what power represents the population of the colony on day 7? Well, it's the power of 7. So it says, write an equation by writing your answer to the problem 2A equal to this power. So 2A, that would be 2 to the 3 times 2 to the 4 equals 2 to the 7. So how are the exponents in the equation related? Well, in this case, 3 plus 4 equals 7. So this 7 is a product of the exponents on the left. Explain why you can write the product of negative 6 to the 23, negative 6 to the 23 times negative 6 to the 15 as a single power of negative 6 to the 38. Well, the base stays the same. And what we do is we add the exponents. So that'd be 23 plus 15. And that would be negative 6 to the power of 38. Okay, so multiplying. Whenever we're multiplying the same base, the exponents get added. Last page, session 2. Oh, it's not the last page. There's no one after this. So this says apply it. Use what you learned to solve these problems. Which expressions are equal to 7 to the 4th times 7 to the 8 over 7 squared? Well, 7 to the 4th times 7 to the 8th is 7 to the 4th plus 8 over 7 squared. Well, this would be 7 to the 12th over 7 squared. Okay, and then we take 7 to the 12th minus 2, because when we're dividing, we subtract exponents. So when we're multiplying, we add, and when dividing, we subtract. And this becomes 7 to the 10th power. So this is, and 4 plus 4 is 8, plus 2 is 10. So that is equivalent. This is not. 7 to the 2 to the 5, that is, because 2 times 5 is 10. Then we distribute. We've done that, so it's D. And this is 7 to the 15 divided by 7 to the 5, so that's 7 to the 15 minus 5, which is 7 to the 10. So E is an answer, and F is not. So it's A, D, and E. Number 6. Evaluate the expression when n equals 2. Show your work. So now what we're doing is substitution. That's what this is called. And we substitute in the value for the variable. So I'm going to rewrite 3 to the 3rd times 3 to the n equals 2. Here's an n. Let's change it to 2. That's all we had to do here. Okay, and then we find the value of that. Well, the bases are the same. We're multiplying, so that tells us to add the exponent. So this is equal to, oops, thinking of the exponent, 3 to the 3 plus 2, which is 5. Okay, we're not really worried about Evaluate the expression. Okay, I guess we could continue. 3 times 3 is 9, times 3 is 27, times 3 is 81. 81 times 3 is 243. I had to think about that a second, right? 81 times 3, 3, 8 times 3 is 24, yes. 243, or it's also 3 to the 5th power if you left it as an exponent with one digit. Okay. Number 7, evaluate this expression. Okay, so this is a little bit different. We have a negative 2 to the power of 3 all over negative 2, and that's all inside something cubed. So let's work the inside first. So order of operations says to do grouping first. So I'm going to focus on the first step, which is negative 2 to the 3rd power. So that's negative 2 times negative 2, which is positive 4. Positive 4 times a negative 2 is negative 8. So it's going to become negative 8 over negative 2 to the 3rd power. So that grouping is done. The next step I'm going to focus on is the next grouping, which is inside the parentheses, and that's division in this case. So this is going to become a negative divided by a negative is positive. 8 divided by 2 is 4, and it's going to be 4 to this power here. And now we can say 4 times 4 is 16. 16 times 4 is 64. Okay, so that's the answer to this problem. Okay. Practice. Applying properties of powers with the same base. So study the example showing how to simplify an expression involving powers that have the same base, then solve problems 1 through 5. So look at the example right here. Rewrite this expression, 6 to the 9 times 6 to the 4 divided by 6 to the 11 as a single power. So they wrote this here, and they gave the rule, when we multiply, we add. So 6 to the 9 plus 4 over 11, which is 6 to the 13 over 11. And when we divide the rules, subtract them. So 6 to the 13 minus 11 is 6 squared, which is 36. Okay, so that's the rule we're going to follow. Those are the rules we're going to follow to do these two problems here. So rewrite each expression as a single power. Well, we have a base of negative 4, and we have a 6 and a 5, and we're multiplying. So whenever we multiply, the exponents get added. So this would be negative 4 to the 11th. Okay, so we're done. They don't want us to figure out what negative 4 multiplied 11 times is. It's just as a single power. So we're done. That's it. C, we have the base 9. Always check, see if the bases are the same. And then you take the exponents when we're dividing and subtract. So 9 to the 14 minus 7, that's a minus, is 9 to the 7th power. B, we have a 13, we have a 13, so we can do this. The bases are the same. We have a 7, we have a 2, we're multiplying, so that means to add exponents. So this would be 13 to the 9th power. Okay, and negative 24, our base is going to be negative 24. And the exponent to the numerator is 5, and we're dividing, so it's minus. And the power of a number without anything up here is a power of 1. Be careful. Powers of 0, anything to the 0 power is 1, and we haven't done that yet. So if there's a number there, it's to the power of 1. So negative 24 to the 5 minus 1 is negative 24 to the 4th power. 2, a population of bacteria cells reproduces so that after X hours, the population is 15 to the X bacteria cells. How many times as large is the population after 24 hours than after 8? Write your answer as a power of 15. Show your work. So I'm going to take, we're focusing on 2 different days. Okay, write your answer as a power of 15. That means the base is 15. That's where this came from. And we're worried about the 24 hours and the 8 hours. So we did this already on the first page, but we spent a lot of time figuring it out. Now that we know the rules, it's really quite easy. So we're going to take, and 15 to the X is our expression we're using. And the number of hours is our exponent. So we want to divide the 24th day hour by the 8th hour. So it's going to be 15 to the 24th power divided by 15 to the 8th power, which equals 15 to the 24 minus 8, which is 15 to the 16th power. Okay, and that's it. That is the solution. And I believe that brings us to, no, it doesn't. There's still another practice page. Let's keep practicing. Okay, so now this is 2 to the 1. Whenever there's a number and no exponent, so we're multiplying bases, so it's going to be 1 plus 5. So that's going to be 2 to the 6. Okay, so what I would recommend you do here, I should have said this before I did A. Pause the video, see if you can do these, if you haven't already, and then unpause them and check. So on part B, I have a base of negative 10 to the power of 4, and we're multiplying, so that's going to be an addition, and then you get negative 10 to the 7th power. Now it says to evaluate each expression. Okay. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So the answer to A actually is 64. Okay, 2 to the 6th power, which is 64. And then what is negative 10 to the 7th power? Well, it's going to be negative and 10 with 1 with 7 zeros. Okay, that's the 10s are easy. So that's going to be negative 10 million. C, negative 11 to the 3 plus 6 over negative 11 to the 7. Negative 11 to the 9 over negative 11 to the 7. That's going to become negative 11. Okay, and these all should probably be in parentheses, shouldn't they? Because if I don't put parentheses, that's not the same number, because we'd have a negative 1 after. Okay, so negative 11 to the 9 minus 7, which is negative 11 squared, which is 11 times 11 is 121, and a negative times a negative is positive, so it's 121. Okay, I didn't put a box around this, so I will. This is the answer to B. All right, let's take a look at C or D. 3 squared to the 7th is 3 to the 2 times 7 over 3 to the 10. 3 to the 2 times 7 is 3 to the 14 over 3 to the 10. And then dividing, we subtract. So it's 3 to the 14 minus 10, which is 3 to the 4th power, which is 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay. E, 10 squared times 10 cubed, all squared. Do inside first, 10 squared plus 3 squared. That's going to be 10 to the 5th power squared. Okay, and the rule says to multiply, so it's going to be 10 to the 5 times 2, which is 10 to the 10th power, which is, okay, I'm going to move this one down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. Okay, so that's 10 billion. Okay, so now we're going to do F. Again, you work inside first. So 4 to the 7th divided by 4 to the 5th is 4 to the 7th minus 5. And that quantity is going to be squared. Okay, so when we take 7 minus 5, we're going to get 4 squared, which is 4 to the 2 times 2, which is 4 to the 4th power. So that would be 4 times 4, which is 16 times 4. 16 times 4 is 64. 64 times 4 is 256. Number 5. Our bases are the same, so we can do it. Negative 3. And then the numerator is 2. And it says to evaluate each expression for when n equals 4. So it's 2 times 4. Okay. So that's just this divided by negative 3 to the 5th. Okay, so that's going to be 8, right? 2 times 4 is 8. So this is going to become negative 3 to the 8. And we subtract exponent, so it's 8 minus 5. So this is going to be negative 3. And I should have parentheses here, by the way. And negative 3 cubed. So 3 times 3 is 9 times 3 is 27. And a negative to an odd power is negative. So it's negative 27. Okay. And B. Okay, again, n we're going to substitute in for as 4. So this is going to equal 8 to the 4th power cubed divided by 8 to the 10th, which is 8 to the 4 times 3 over 8 to the 10th, which is 8 to the 12 over 8 to the 10, which is 8 to the 12 minus 10, which is 8 squared, which is 64. Okay, so there's all kinds of rules going on this one. This is powers of powers where you multiply. And so that's what I did here. And then division, which is subtraction. And then we finally get our final answer. Okay, and now finally C. Let's move this up a little further and take a look at this one. Okay, so n is 4. So let's first rewrite this with it substituted in. So this is 2 cubed times 2, and the n is right here, so there's a 4 there. Okay, and then that's all to the 3rd power divided by 2 to the n, which is 4, to the power of 5. Okay, so this seems a little bit more daunting, but it's not bad. Okay, so just do one thing at a time. Focus on the numerator now, or in the parentheses in the numerator. So let me highlight that. This is what we want to do first. We want to do the parentheses first. So that is going to be 2 to the 3 plus 4. That's the rule. Okay, all to the 3rd power. And this will be 2 to the, and then we can multiply these. So show that as 4 times 5. Still inside here, we're going to get 2 to the 3 plus 4, which is 2 to the 7. Okay, that's 2 to the 7. And then this 3 is still outside here. And then 4 times 5 is 2 to the 20th. Okay, and this rule is power of powers, and that says to do 2 to the 7 times 3 over 2 to the 20. And 7 times 3 is 21. So we have 2 to the 21 divided by 2 to the 20. And the rule says take your base and subtract your exponents. So this is 2 to the 1, which is simply 2. Okay. All right, so this whole mess here when putting 4 in for n came out to be just simply 2. And that brings us to the end of session 2. Thanks for watching and have a great day.